10.7, I'm going to write it up here. E to the first power, we're going to round, is 2.7. E squared is 7.4, rounded, of course. And then e to the negative 1, which would be 1 over e. That is going to be rounded to 0.368. And that's truly going to be enough for us because everything else is going to be off the graph. We wouldn't have enough room to graph it. All right, so it may surprise you to learn that for most real-world applications involving exponential functions, the most commonly used base is not 2 or 10, but an irrational number, e, and it is called the natural number because it occurs in nature naturally. All right, we're just going to graph it as an exponential function. So here we are with its most basic form. So we're going to plug in negative 1, 0, 1, and 2. And we're just going to recall these numbers up here that we've written at the top of our page. So e to the negative 1, let's write an output of 0.368. E to the 0, of course, is anything to the 0 power. So this is going to be a 1. E, natural E, is 2.7 rounded. E squared is 7.4. Now, just like all exponential functions, guys, no matter what, it will never equal 0. And there's no way that you're going to be able to turn it into a negative number using an exponent. So you're still going to have an asymptote here. And of course, that asymptote is going to be at y equals 0. All right, let's plot these points. So just kind of estimate the best you can on 0.368. Plot those dots the best that you can. And we're going to make sure that it is most definitely up on the right-hand side of the graph. There we go. So that's going to be the exponential function with a base of e. All functions have a domain of negative to positive infinity. But remember, it's impossible to make this equal 0 or negative, so the range is from 0 to infinity. And we're just going to review end behavior one last time, y'all. So we're going to have x approaching negative infinity. We're going to analyze those outputs. So here's the negative infinity symbol, or the arrow. Notice that this graph is getting closer and closer to 0. It's getting smaller and smaller. It's close forever to 0. All right, now let's talk about the positive infinity arrow. As your x values increase, so do your outputs. So both of them are approaching positive infinity. Very similar to yesterday. The only thing that's changing is we're always going to use the same base. Let's look at number 2. All right, so for problem number 2, you've got your translations coming back. Let's talk about what those translations are. Your graph is going to be shifted 2 places to the left, and it's going to be shifted 1 place down. So again, if we move our starting point, we are going to address both of these translations at the same time. So let's move our starting point 2 places to the left and 1 place down. Guys, I forgot to write my negative right there. Make sure you have negative 2, negative 1. 2 places to the left, 2 places down. So my brand new origin, my brand new starting point is going to be right here. Also remember you have a horizontal asymptote at your k value of negative 1. So let's go ahead and extend that horizontal line out. right, now what we're going to do is we are going to make a t-chart. So let's go ahead and make a t-chart right here of x and y. And remember, I'm just going to go to the top real quick. These are the only exponent numbers that will fit on our graph. So we're going to do -1, 0, 1, 2. And remember, we are only applying these exponents to the base e. And now this is going to be the same thing as it was up here. So here we go. E to the -1, remember, is 0.368. E to the 0 is always 1. E to the first, we're rounding to 2.7. E squared, we're rounding to 7.4. And remember, all of our ordered pairs are based on our new origin. So from here, we're going to go over -1 and kind of estimate where 0.368 is. Now I'm going to plot 0, 1, 0, 1, and then all right, so here's the curve. Let's just draw this the best we can. All right, and then that's going to be the function with a base of e that's been translated 2 places to the left and 1 place down. Any questions on that? Let's do it one more time. All right, let's go ahead and take a look at number 3. So look, on number 3, you have a negative in front of your x. Y'all, that is a sideways reflection. It's a reflection across the y-axis. And you don't have to really know that formally. If you just know it's sideways, that's good. But that is the formal description for it. Let's address our translations. We only have one translation. It's just going to be up 5 units. So my HK, or my new starting point, is at 0, 5. So I'm going to draw my little cross here to indicate my brand new starting point. Also remember, we have a asymptote at y equals 5, so we're just going to extend this out. So this graph is shifted pretty far up, guys. All right, let's draw our t-chart, and please remember, it is only going to be applicable to the base of e. So we're going to plug in -1, 0, 1, and we could plug in 2, but I'm not going to require you to memorize -2, and I'm going to show you that. All right, look, when we plug in a -1, there's already a negative there, so it changes to e to the +1, so we're going to have 2.7 right here. 0 always gives you an output of 1. Now look, when we plug in 1, it turns negative. So over here is where you're going to write 0.368. For 2, remember it is going to be 1 over e squared, which is 1 over 7.4, and this is going to be 0.16. And again, that's almost impossible to write. Just remember, let me go back up to the top of my page. These are the only ones that you really have to have memorized. All right, let's go ahead and graph what we can. We can graph -1, +2.7, 0, 1 for sure. And then I am going to graph +1 and then 3.68, just kind of estimate where that is. And that's going to be enough for me to kind of see the shape of this. And here it is. Remember, it's reflected, so it's going to be down on the right side of the graph,